Welcome to the second lecture in Module 1. This one is really about basic small unmanned aircraft information. This lecture should help you understand the big picture. So let's go to the first slide. Now, first of all, I keep referring to SUAS, or Small Unmanned Aircraft Systems, and not just unmanned aircraft vehicles or drones. And the reason I do this is because it is really a system. And that system consists of many different elements. So let's take a minute to talk about those. First of all, you have the operator or the pilot of the SUA. That's you. That's the person that's going to actually go out and fly with their vehicle. And you'll be doing that using a ground control station. And you might not think of a small handheld controller as that's in your hands as a ground control station, but really that's what it is. It's a system that's used to go back and forth and actually be able to have telemetry or control of the UA, and also receive video and feedback from the UA, and as needed in order to be able to perform the mission or the actions that the operator wants. And of course, you have the UA itself, the vehicle portion of the UAS. And you have a payload, and in this case, showing a small high-def camera. You'll have the support equipment. It might be extra propellers, it might be a case, your smartphone, with some later FAA software up and running so that it can tell you what the airspace is doing around you, weather, for instance. You might have extra power supplies to charge your system, but really that creates the SUAS environment. And this environment is similar across both small platforms and larger platforms. It's just scaled accordingly. You may think of an operator, in this case, just having a small quad rotor and maybe a box of extra parts. And that might be the case, but if we were to take it one step further, this operator could actually be within a mobile van that's using high power telemetry and video links, talking to large unmanned aerial vehicles with a payload, for instance. And that could be the broad scope of different items. There might also be an entirely different trailer outside which has the support equipment and the maintenance personnel to actually be able to go out and support the UAV. So don't look at it as really you being any different in the process of the flow that occurs within what we call the SUAS, or that system. That system is similar across multiple platforms, multiple users, but the size can vary. The cost most certainly may vary, but the basic concept of being an unmanned aircraft system is that it's very important to remember, and it's common across multiple platforms and users. Let's go to the next slide. So why use a UAS and what's their purpose? There's a lot of news, obviously, about such systems as the Predator being used for military operations, and obviously that receives a lot of news. But some of those same types of systems are being used by research groups, including such government agencies as NASA, to be able to do environmental research, meteorological research, and an entire gambit of different aspects that the platform can carry, different sensors to do their job. There's new platforms being developed as well for agriculture use, for general surveillance, and in this case I bring up the in situ platform that's shown, as it is really being used in different areas to help civilian entities rather than just military, specifically the fishing industry and the railroad transportation industry. And this really continues to have a broad scope of use in both as I said, the military and the civilian environments. Of course, there are many quadcopters out there being used for really everything from agricultural research to photography, real estate, commercial, and public use for law enforcement. A broad array of different things that are being developed for such systems, and many of them being developed on the fly, pun intended, I guess. Things that had not been thought about before that a UAS could do are actually being dreamed up and deployed every day. Fixed wing operations and small aircraft that are being able to go out and actually search for cattle, search for wolves or impact of wolves in some environments, actually inspect roads after heavy snows. Police departments and public use is occurring all the time. They're using rotary wing aircraft to work electrical lines, and by that I mean actually go up and inspect electrical systems. Things that use to be done by a manned operator or a hoist or a crane or even a helicopter are now being done with UAS. And that's really the reason we call it an unmanned aircraft system. And here at Embry-Riddle, we are starting to integrate that into our curriculum programs. We even have a space aspect discussing things such as the X-37, which NASA is involved in. But also, unmanned systems can be probes. Think about that. Out there investigating other planets within the solar system or beyond. On this slide, let's talk about the different categories and classes. So SUAs come in many different categories and classes, and it can be pretty confusing because there's many different descriptions out there that discuss the altitude that can be flown, the weight of the aircraft during takeoff, how fast the system goes, etc. But given the recent rulings by the FAA, a better method or straightforward method to describe UA might be the one shown here. It essentially breaks the UA into categories 0 through 3, and by doing that, we consider max gross weight takeoff, and that really helps us identify which category it's in. Specifically, category 0 would be those ones that are 0.55 pounds or less. These don't require any FAA registration under these new rules. Next would be category 1, or 0.56 through 55 pounds, and these are generally the ones that you're seeing quadcopters and the like that are out there pretty commonly today. And these include recreational categories, but they do require registration under the new process. Once we go up to category 2, from 56 pounds and above up through 1,320, any of you who are sport pilots might recognize that 1,320 pound max gross weight takeoff that essentially limits a light sport aircraft as well. And then, of course, there's anything above 1,320 pounds. But in this way, we focus on the weights and not necessarily the altitudes and other speed issues of the UA when we make a category decision. This will become more important as UA continue to advance, and smaller UA are capable of flying to higher altitudes and speeds, at greater speeds, I should say, as the integration into the NAS takes place over the next decades. So can you legally fly a UAS? Yeah, let's discuss that for a minute. One of the first questions you should ask yourself is, can you legally fly an SUA? And really, I state that a little bit differently. The real question is, what type of UAS operator are you? So you can be a public or government entity, which includes state governments, law enforcement, universities, first responders, etc. Or you can be a non-government entity or a civil user. And sometimes we'll talk about commercial for business and profit. A private university, so for example, Embry-Riddle would be considered a non-government entity because we're a private non-public university. Additionally, entrepreneurs flying for business pursuits in general are going to be considered those as well, those non-government entities. And finally, you could be someone that's actually manufacturing UASs. So all of these different users require a different type of approval process. Now, obviously, the individual or the hobbyist, which are the majority of the people that are probably signed up for this course, are going to be recreational users. So they can go out and fly as needed. You can go ahead and register your SUA if it meets the weight requirements, and we'll talk about that in a minute, and then you're good to go. Following the rules, obviously, is required. However, if you're a public government entity, you now have to go through a fairly lengthy Certificate of Authorization, or COA, process. And the COA can take a while to get that approved and go through. It's probably getting faster and faster now that the rules are out. Likewise, a civil or non-government remote pilot becomes certified through the Part 107 or Part 61 process. Additionally, your SUA is likely to be needing to be certified, depending on its weight, to operate in the NAS. The registration number can be used on any airframe you fly, and in some cases, you could even register for a N number, which applies to certain conditions. So what we're really talking about is the platform being authorized to fly as a safe platform within the NAS. And then your license comes into play, or certificate. The approval of the operator and his or her capabilities to go out and fly is really what I'm talking about. And to do that for very specific reasons as well. All of that is a part of the approval process that the FAA has for us to go through. Small unmanned aircraft operators who want to fly outside the requirements of this small UAS rule, or Part 107, can request a waiver or an airspace authorization to get that waiver approved. And this is an electronic form. Applicants would complete the form that identifies a list of the regulations that are eligible for a waiver, but there's strict performance-based standards with these. These include subparts of Part 107, such as operations from a moving vehicle, daylight operations only, visual line of sight, operation in certain airspace, altitude, visibility and weather, and several others. The FAA tells us that they will strive to complete the review and adjudication of waivers and airspace authorizations within 90 days. This process is not for modelers or hobbyists flying in accordance with the special rule for the modeling aircraft. The UAS manufacturers, just like manned aircraft manufacturers, may go through a type certificate process. They want to be able to go out and prove that the UAS is worthy and safe to fly in the NAS, which will allow it to be considered for a 333 exemption and right on down the line. So let's talk more about this in Module 2. It's a complex area, but it's the current system. It's going to be out there for a while. So it's worth talking about a little bit. And we'll, again, talk about more of that in Module 2. So first things first, before we go on. For those of you that are recreational or hobby users, and the UAS that you have is not a zero class, that under 0.55 pounds, then you're required to register before you take your first flight in the National Airspace System. If you have doubts about that, and if you go to the FAA link, which is provided below, and that's very easy to do, it takes maybe 3 to 5 minutes to register yourself to fly a UA. And then you'll be able to get a standard registration number for any UAS that you fly. If you have any doubts as to some of these questions the FAA may throw out at you, or some of the things that you need to do to be legal and safe to fly, tune into Module 2 of the MOOC here, and some of that will be covered as well in the remainder part of Module 1. Again, a lot of websites, a lot of sources out there to help you fly safely and answer those questions. So thanks for listening to this second lecture of Module 1. And now I'd encourage you to move to the next lecture, which is number 3. We'll talk about the systems part of the small UAS.